Welcome to This Explainer. Today, we are diving straight into a dark, thousands of years old mystery. We're talking about a blinking star that literally terrified humanity for millennia and seemingly broke the fundamental laws of physics. It's a cosmic puzzle that has fascinated and honestly frightened observers since the very dawn of recorded history. And I mean that literally. For over 3,000 years, completely unconnected cultures across the globe all looked up at the exact same star and thought, "Yup, that's bad news." In Greek mythology, this star was the decapitated head of Medusa. In ancient Chinese astronomy, it was part of a constellation mapped out as a mausoleum, and its name roughly translates to piled up corpses. I mean, yikes, right? So you really have to ask, why this one? Out of the billions of stars up there, why did ancient stargazers single out Beta Persei, the second brightest star in Perseus? When they looked into the cosmos, they didn't just see a point of light. They saw a celestial demon staring right back at them. What exactly were they seeing that freaked them out so much? Well, it all comes down to its downright eerie behavior. You see, stars are supposed to be constant, right? They just sit there and shine. But not Algol. Algol eerily dims, and then it brightens back up. It's this creepy, blinking cosmic mystery that our ancestors just couldn't ignore. And it actually took humanity centuries of scientific advancement to finally figure out what was going on. It is wild to look at the timeline on this. We're talking 3,200 years ago. Ancient Egyptian calendars were already tracking its phases, literally logging it on their lists of unlucky days. Fast forward to the 17th century, an Italian astronomer, Gimignano Montanari, officially documents it dimming every few days. But the real aha moment didn't happen until the 1800s, when Edward Pickering at the Harvard Observatory made a massive breakthrough. Pickering dropped a bombshell. Algol isn't just one star, it's actually two. It's a binary star system. He realized that you have this bright, hot main star, and it's being orbited by a smaller companion. So from our perspective down here on Earth, when that smaller companion crosses directly in front of the bigger parent star, the entire system suddenly looks dimmer for a few hours before going back to normal. Mystery solved, right? Well, not quite. Which brings us to the rules of stellar aging. Because to really understand this binary setup, we actually have to uncover a history of extreme cosmic violence and a massive contradiction in astrophysics. To get why this is such a paradox, we first have to establish the ironclad rules of how stars live and die. Basically, gravity is constantly pulling inward, trying to crush a star. The star fights back by burning hydrogen fuel in its core, which pushes outward. Now, here is the golden rule. The larger a star is, the more intense its gravity, which means it has to burn through its hydrogen way faster just to survive. Because of this, massive stars die significantly younger than smaller ones. Now, both stars in the Algol system were born at the exact same time, from the exact same stellar nursery. So, following those strict physical laws, they should be aging side by side, living out their lives on what astronomers call the main sequence. That's just the stable, everyday, hydrogen-burning phase of their life cycle. But here is where we hit the impossible star paradox, because Algol completely shatters that fundamental law of the universe. It creates a scenario that simply should not exist. When you look at the two stars side by side, the problem becomes super obvious. Algol A, the primary star, is absolutely massive, but it's still young and stable on the main sequence. Meanwhile, Algol B, the companion star, is way smaller in size, yet it's already a dying subgiant. It is nearing the very end of its life. Let that sink in for a second. If larger stars burn fuel faster, and these two stars were born at the exact same time, how on earth is it possible that the smaller star is dying first while the massive one is doing just fine? It completely contradicts everything we know about how stars work. Scientists were absolutely stumped. This became known as the Algol paradox. And the stellar vampire solution to this puzzle? Well, it's honestly just as dark and macabre as the star's ancient mythology. The answer lies in a chaotic, incredibly violent cosmic mechanism called mass transfer. This happens when two stars orbit dangerously close together, and one star's gravitational pull gets so strong that it literally strips and steals the outer atmosphere right off of its companion. So here's exactly how it went down in the Algol system. Back in the day, Algol B was actually the larger of the two stars. Because it was larger, it naturally aged faster. As it hit the end of its life, it swelled up into this huge red giant. It got so big that it literally overflowed the gravitational boundaries between the two stars. And that allowed the originally smaller star, Algol A, to just step in and start stealing all that hydrogen for itself. It brilliantly illustrates the sheer brutality of the universe. As the source material puts it, Algol A acted like a stellar vampire, preying on its own sibling and draining its material just to extend its own youth. So Algol A is a total fraud. It isn't naturally young at all. It is artificially extending its lifespan by gorging on the lifeblood of its dying companion. It stole its sibling's mass to become the brilliant, massive star we see today, leaving behind nothing but a stripped, dying core.
It's crazy to think about. Those ancient Egyptian, Greek, and Chinese astronomers couldn't possibly have known the complex astrophysics of binary mass transfer. Yet, they accurately sensed something sinister in this blinking, cannibalistic star system. They recognized a demon when they saw one. Which really leaves us to wonder, as we gaze up into the vastness of space tonight, what other monsters are hiding in the dark?